Looks like the stream is running. Hi everyone, I'm TigerHawk T3, and today we're going to write rock, paper, scissors. Because I feel like it. So that's what we're going to do. It's going to have 3 difficulties. Easy will be you always win. Hard will be you always lose. And medium is random. Gonna need that. Let's set up our choices. It's going to be a dictionary of dictionaries. Choices equals easy. There's another dictionary with, stuff. And let's go back to here. Medium and hard. Actually, let's make this E. M. And H. We're just going to do the first letter and make sure it's lowercase. And so we'll have rock will be, if we're easy and we pick rock, that means the computer has to pick scissors. And if we pick scissors, the computer has to pick, this is going to be against the computer, by the way. Rock beats scissors, scissors beats paper, and paper beats rock. Very good. Didn't really need that, huh? There we go. It's going to be similar to this, actually. Put that in there and modify it. So rock, we will perhaps not have medium, because that's going to be random. Technically, if we wanted, if we put random dot choice rock, paper, scissors, we could sort of do that and it would do something, but it would be the same each time, because it would be, we would create this dictionary and then Python, the interpreter, would evaluate it when it creates a dictionary, and that would be that. It would pick something random and that would be it. What I could do is do lambda with this, and then I would just call this, and I could put lambdas everywhere. My god, that would be awful. Certainly could. Actually, I don't really mind. A lambda is an inline anonymous function that contains an expression, and that expression is evaluated and returned. So it's basically an implicit return this. So this function returns the value scissors. If you want to have basically an empty lambda function, it's not lambda pass, because pass is a statement. It would be lambda none, because a function with just pass in it, or a regular one, I mean, would implicitly return none. So that's what that would be. But here, let's take this here, rand equals that, That's a terrible idea. Look at this. I have a function. I have a lambda function, anonymous, and I'm giving it a name. Why do that? Do not do that. All it does is make things harder to debug. Return. Great. Random.choice, rock, paper, scissors. Okay. Let's actually... this. Keyword arguments. This says quickly gotten. Very weird. Filled with lambdas, whatever. Mutable default argument. These are bound when you define the function, not each time it's called. So if I were to modify L, it would show up in subsequent calls, these changes. That's why if you do, if you have a default of L equals, an empty list, for example, so if someone doesn't pass in a list, you just start with an empty one. It's one list shared between all the times you call the function. Often not what people want. Let's put this afterward. Actually, no. Can't really do that. Rand. Okay. Alright. Does this even matter? Because they're all the same. Should I do this? I don't know. I'm not too happy about this. What I can actually do... Should I be calling everything? You know what? I'm gonna take these out. I don't like that. I'm gonna take out medium. I don't think it belongs there. Okay. And rock is beaten by paper. Scissors beaten by rock. How do I spell scissors? Scissors, there we go. Let's move that over here. Alright. So we have easy, we have hard, we have something that returns a random thing. Alright. Here's what we'll do. About I equals nothing. Let's start with that. We're gonna have an infinite loop to do things. I equals actually while I not equal to q. I equals we're gonna take input. Enter a difficulty or play, and we're going to lower it, and we're going to take the first character. All right. Enter difficulty, play, or quit. This should just be, don't need that. If I is Q, break. Fantastic. Otherwise, we know it's something. If I is in easy, medium, let's make a set. Easy, let's do it this way. Easy, medium, hard, rock, paper, scissors. And I do this, put it in a set instead of just leave it as a string, because then they could enter EMHRPS or any part of that, because the substring of multiple characters is still there. But if I change it to a set, each element will be a single character only. Let's do if I not in this set, then we continue, meaning go back to the top of the loop. Otherwise, should I just have these all be lambdas? Fine. Let's make it consistent. I don't know. Nothing. Great. No. We don't need that. So I'm going to have these be called anyway. All right. And now we're going to print. How about computer plays something. Dot format another thing, and we finish the print call. What are we going to put in there? We're going to have the difficulty equals default is going to be easy, I guess. If I in set easy, medium, hard, difficulty gets whatever I is. Otherwise, if I is in the set of moves, we're going to print that. Else, we don't need an else. I was going to say else continue, not necessary. Okay. Can this be first? I don't know yet. What have we got? As Bilbo said when telling riddles in the dark, what have I got in my pocket? He wasn't quite sure. We're going to get input from the user, make it lowercase, get the first character. If it's Q, we're going to break, and we will stop the game. If it's E, M, or H, that's going to be our difficulty. If it's not any of those, but it is either R, P, or S, then we're going to do choices.get something. We're going to get the difficulty. Actually, I think we can just do choices.get difficulty because we're sure it will be one of those. Don't need to get there. choices with that difficulty? Actually, yes, we do. Difficulty, and it's not there. If the difficulty is medium, meaning it's not there, we're going to return an empty dictionary. And then from that, we're going to get something else, I, and if I is not there, we will have rand. And then we will run it. That's fun. What a mess, but I think, I don't know. Not something a beginner would necessarily write, I think. But it seems fine. So what did I just do? The dictionary get method attempts to look up a key in a dictionary, retrieve its value, and return that value. If the key is not present in the dictionary, it returns none by default instead of crashing, giving you a trace back with a key error. It gives you none by default, or you can specify you can pass a second argument, and it will return that instead. So we're going to access our choices dictionary, and we're going to attempt to look up the difficulty key, and if it's not there, let's pretend it is there. So if we have E or H, that will produce the corresponding value being this other dictionary. And then from there, we will try to access the key I, which is R, P, or S, and we're going to get those, and that'll probably work if we have one of these dictionaries, because those are the only possible values. And then it will return one of these functions, and then it'll call the function and give us whatever value that is. If we look up our difficulty, and our difficulty is M for medium, it won't be found in here, so it'll return the default value, and we gave it a default to use, and that is an empty dictionary. And then we will look in that empty dictionary, and we will attempt to get something. It's not going to be in there because the dictionary is empty. There's guaranteed whatever you're looking for in there, you're not going to find it. And so it'll give us the rand function. And then it will call that function and return a choice of these things. Let's run it. Let's save it first. Rock, paper, scissors. Documents, scripts. Okay, let me turn on this. What's it? Fantastic. Rock, paper, scissors, and let's see what happens. What did I do? Where's that? Oh, forgot a colon. Oops. Let's try again. Enter a difficulty. Or play or quit. Let's try quit. It's done. Great. So that works. Easy. Okay. How about we play rock? Rock. I don't care. If it's on easy and we play rock, the computer should play scissors. Computer plays scissors. Great. How about paper? The computer played rock, and so we win. How about scissors? Computer plays paper. Great. Now let's try medium. How about R, P, and S? Scissors, rock, scissors, looks random. This random. How about hard? Let's go rock. Oh, the computer played paper. Let's do rock again. Try to switch it up. Confuse the computer. It didn't work. One more time. I don't even have to spell it right. It doesn't matter. Okay, how about this? Nope. Doesn't like that, but it doesn't crash either. How about paper? Computer played scissors and won again. Let's try scissors, that winning thing. Oh my god. It keeps winning. So there you go. Q. This version, 22 lines, that's pretty good. I guess I like that. This version assumes that you will kind of do the calculation in your head of who won. Some versions of rock, paper, scissors involve a scissor is called a knife. That's what a scissor is. A pair of scissors is two knives that you kind of pin together and then snip, snip. Some versions of rock, paper, scissors tell you who won. Since we have, if we only had easy and hard, this would be extremely easy to say who won, because if it was easy mode, we would say you win every time, and if it was hard mode, we would say you lose every time, because that's what happens. But medium, we would actually have to, you know, check. Fine, let's do that. Fine, you convinced me. Outcomes equals another dictionary. Easy is going to be how will this look? Medium is going to have, let's look at medium, shall we? Medium will be a dictionary, and it will have let's say it has your move and the computer's move. Rock, rock. Rock, paper. Rock, scissors. Paper. Rock. Paper, paper. Paper, scissors. Scissors, arm. Scissors, P. Scissors, S. I wanted one of these characters. Thanks. Okay. So it's going to look up this and say, I know what this will be. Actually, I want all of these to be the same. Let's look at this part first. Computer equals. Let's do that. Thank you. Choices. This. What's it? That's part of the format. We don't want that. Okay. Pick what the computer does. Result equals I plus C. You and the computer. Let's say, do we have medium? We want easy and hard to both be kind of default values. Tell you what we'll do. We won't have them in a dictionary. I can actually just do that. Yeah. Okay. One space fewer. Very good. I'll figure out what those are later. And actually, I think I can remove the ties. And I can just have that be a default. Okay. If difficulty is easy, I don't know. You win something equals you win. Okay. If difficulty equals, oops, that's wrong. Need two of those. My bad. Is hard. R equals you lose. I want to do it all in that dictionary. Oh well. Else, R equals medium, and then we look up the result. Okay. And then R. This got rather large. 34 lines, huh? Okay, let's fill this in. That's if you pick rock and the computer picks paper equals you lose. If you pick paper, no, if you pick rock, this is you win, this is you win. pick paper and the computer picks scissors, you lose. This is you lose. And the rest are you win. Okay, very good. Oh, no, we gotta do dot get result tie. Alright, very good. I'm kind of cheating on PEP8, the style guide. These should be on separate lines. I'm gonna do that. Cause, yeah. Then you can tell that there's a branch there. How about... I like this bit of magic. Get an empty dictionary, and then get and have another default with a thing, and then call everything, and have lambdas in there. I don't know. I think that's pretty much it. Let's test that out. Let's do hard mode. Let's pick rock. That's wrong. Oh, I have nothing in the format. Whoops. C. Right. Let's try that again. Let's pick rock, and the computer plays scissors. You win, because of course you do. Actually, why do we even need this? This is actually unnecessary. This is already all the results. Why did I even do that? All right. Results. Because it doesn't matter what the difficulty was, it's easier to just look it up in the thing. Okay. Let's save that and quit here and then start it again. How about we pick, we're in easy to start, rock. That's not right. I played rock, computer plays scissors, and it says tie. That ain't right. R, S, should be you win. That's strange. Why is it doing that? Is it doing that a lot? It is. Everything is tie. Can't find it. What is it looking up? I, doing R, P, or S. Plus C. Oh. Right. This is not the first letter. I know how to fix this bug. Not a difficult bug to fix. You win. You win. You win. You win. Anything I do, I win. How about hard mode? You lose. You lose. You lose everything. You lose. Let's do medium. I play rock, and computer played scissors. You win. Let's play rock again. I won again. Oh, this time the computer played paper, and I lost. Scissors again. The computer played rock as well. Scissors, tie, and you lose. Let's do it again. And tie, and then you lose. And let's do this. And that's the game. Do I look up? Yeah, I look up the difficulty, so we need that. Okay. That's rock, paper, scissors. So, yeah. Just barely fits in this arbitrarily sized window. 31 lines. That's not bad. Could probably have another space here, but this is kind of our starting variables. I don't know. I think it's fine. Here's our loop. Maybe I should kind of explain summary overall. We'll need the random module to pick random choices for the computer. And then we define a function with a default argument of a list, which is usually something you want to avoid because it can be can give you surprises. But here it's okay because we're not modifying it. It's fine. I just don't want to have to define this over and over again. So it defines it once, and it will not be defined any more times whenever you call the function. And all it does is return a random item from this list. And I have we have our choices that we can pick. That's the computer's choices that it's going to pick based on our choices. If it's easy, we have a dictionary full of options. That means the computer always loses, and hard means we always lose. And instead of just a string, each one of these is a function. Functions are first-class objects in Python. You can do whatever. You can put functions in whatever situation any other object could be. So this is fine. That's our dictionary. Here's our results, and that's how we find out who won and who lost. We have this that says you lose, you win, etc. And these are if the player picked this and if the computer picked that. All the things for that. Here's we're gonna initialize our variable of difficulty, because maybe the player won't want to immediately pick one. So then we have an infinite loop, and first thing we do is get input from the user. If the user wants to quit, then we stop. Or this could be elif or not. It doesn't matter because there's a break here. So if it is this, and these are mutually exclusive anyway, but you can have problems with two ifs, one after the other, because it will check both. So if the user didn't quit, it'll first check whether the input was Q, and then it will check this. It's not if it's Q, then only go here and check if it's if this was not satisfied. They're not connected like if and elif. And then we check if it's one of the difficulties. And if it is, we set that as the difficulty, and that's all we do, and we go back to the beginning of the loop. But if it's not, here's why I need an elif over here, because actually they are mutually exclusive. Technically, I don't need it, because if I is one of these, then it's definitely not going to be one of these. So I could just have an if over here. So if this is satisfied, it will do this, and without the elif, it will then check this, and it will not be satisfied. Guaranteed, because these are mutually exclusive conditions. I'm going to put the elif back in there so that it doesn't have to check both. Because with the elif in there, if this condition is satisfied, then it won't even look at this one, because it's an elif, meaning else, and then check another condition. But it was, so it doesn't need to go in this block at all. It's not going to do this membership check. Could matter, maybe, if you're checking something that takes a long time to check. I don't know. And then we look in the choices dictionary, and we try to look up the difficulty as a key. If it's not there, if we can't get the difficulty dictionary that we're looking for because it's medium, then we will return an empty one instead. And then we will look in whatever dictionary we got for the user's choice. And if it's one of these, then we'll just return that appropriate function. And if not, we will return this function. And then we will call it. And a function of, say, lambda paper is, here's a function, and it returns paper. That's all it does. And of course, this, when we call it, it returns a random choice from this list. And then we create our result to look up who won. And that's I, which is already the first character. And then we have C0, because C is not just the first character here, because we want to actually print the whole thing. So we have C0 for the result, and then we have our printout that the computer plays, you know, whatever they played, and that's C here, which will be one of these things, you know. And then there will be a space, because that's the default separator, and then we're going to look in the results dictionary and try to retrieve a key of the result and return either the matching value, or if the key wasn't found, we say tie. That's it. 31 lines. I think that's pretty good. Alright. That's rock, paper, scissors. Possibly a little more concise, but complicated. I don't know. I think it's quite nice. Usually you'll see a whole pile of very long if, elif structures. Can be very long. And I don't like doing that. So I think this is pretty tidy. It's nice. The benefit of concise code is that there's less stuff to go through. A simple gigantic pile of ifs is simple to read, but it can take a while to just go through and look through everything, make sure there's no typo on any of the lines. While this is, it's all right there. So there we go. Rock, paper, scissors. No idea what I'm going to do in 2 days, but tomorrow is a game of some kind. So thanks for joining me. If you have ideas for something you'd like to see, let me know in a comment. And I will see you next time. Have a good one.